So in this video, we're just going to go over an important limit that we need for subsequent videos. So this is a limit for right now. What we're going to do is just justify it graphically the same way that we did in homework number 1. We will need to use this limit, so you will need to remember this result because we'll be using it in homework and in lectures moving forward this semester. This is going to be one of the more important limits that we put in our pocket. So the limit is the limit as x goes to 0 of the sine of x divided by x. And what we want to notice right away is that if we tried to plug 0 into the denominator, we would get a division by 0, which makes sine x over x undefined when x is equal to 0. So I graphed sine x over x in GeoGebra Classic 5, and this is what the graph looks like. We know that x cannot be 0 because that causes a division by 0. So even though GeoGebra isn't showing it, there is a hole in the graph right here. You can't actually plug 0 into sine x over x. But graphically, we can take the limit graphically, just like we did in homework number 1. We can let x go to 0 from the left-hand side, and that walks us up the graph this way. And we can take the limit as x goes to 0 from the right-hand side, which walks us up the graph this way. And it looks like, even though there's a hole in the graph right here, it looks like the graph is walking towards the ordered pair input 0, output 1. So the graphical evidence is that the limit as x goes to 0 of sine x over x is equal to 1. And indeed, this is correct. The limit as x goes to 0 of sine x over x is equal to 1. And if you're in a position in homework, for example, where this limit shows up, you can feel free to replace it with a 1 if you see it. We'll need this limit as we develop derivative techniques moving forward.